Okay, so we got a lot to cover, so we're going to start quickly. Welcome to Engineering to Empower, in code that empowers content creation. Before we start, I wish to acknowledge the traditional owners on the land with which we're meeting today. We pay our respects to elders past, present, and we also pay our respects to any other Indigenous and First Nations folks here today. So, I'm Anna Tito.
And I'm Kevin Stoker.
And we are technical leads at Tantalus North in Brisbane. So, bit of background about where we came from. Both Kev and I worked together on Vega Conflict very early on in my career, and then more recently we've worked on City Skylines Remastered. In between those two, I worked predominantly on free-to-play mobile games, things like Ice Age Village, Simpsons Tapped Out, Star Wars Galaxy of Heroes, and Crossy Road, and a bunch of other sort of free-to-play, content-driven games.
And I started out in AAA game dev for a while there, and then moved on to a whole bunch of free-to-play games, and now we're at Tantalus North working on porting games.
Yeah. So where it all began?
So we both have similar stories of waiting until 3 a.m. for a build to get through the build system for a very small change.
And we also both have very similar stories about very small typos in data sets and data things causing complete meltdowns in production that involves lots of panicking, patching, trying to fix stuff up, and a lot of Anna rage. So much Anna rage.
And we've also had stories about having to deploy things in production. At least once, I was woken up at 2 o'clock in the morning after a night of a lot of drinking, and being told I needed to deploy a very small design tweak onto the production servers. Didn't seem like a good idea, but I made sure that they knew that I was not in the right state of mind, and they're going to take responsibility, and yeah, so that's kind of where we all came from. Oh, yes, sorry, this is still me. Sorry, first time doing one of these, so bear with me. So, oops, oh, go back.
There we go.
So we're on that slide. Cool, yes, so the current problem, so this is, sorry, excuse me. So this is the traditional development cycle we have right now. So you have a design document, and then an engineer comes in and implements it, and then there's a whole bunch of playtesting. It could be done from externals or internal playtesting even. Then you evaluate, then someone makes a design change, and then the engineer comes back in and does it, and you do this cycle for a whole bunch of time, and then you release the feature. There's problems with this model. It's very slow, it's expensive, you have multiple disciplines working together, and there's a huge opportunity loss as engineers are making very small tweaks based on design feedback. So what can we do if we remove the engineer from this cycle?
And so just a bit of broader industry context here. I mean, games are a business, but after, prior to this kind of thing, the business model has changed. There's much more live service. We can't do games now with live service. It's either DLC, it's expansion, it's events, it's mods, or even it's patches. Even if you do not plan to have a live service component, the players will expect at least several patches. So how do we actually plan for this world, particularly given the fact that the pressure is to build games faster, cheaper, at a higher quality bar, and with a smaller team? And that little triangle that they have where, it's quality, they're going, okay, no, you need all of them. And we're like, but the whole thing is that you can't have all of them. And like, no, you have all of them. That's why it's a triangle. You're like, ugh. So what we try to do here is work out how we can actually do at least some of this. And we need to remember here that this is a whole team effort. This is not just a programmer task. We'll be teaching you talking about our experiences being on the programmer side, but it's a whole of team effort. This is from designers, artists, production. It's all about us working together to do it. So, what are we trying to do? We're trying to...
You're first.
Reduce, yes, I am first. Reduce design and art iteration cycle times. So we want that to be quicker. We want it to be as fast as possible so that if they're making tweaks, it comes through.
And it's also about reducing errors, and not just reducing errors, but preventing them from actually occurring in the first place.
We want to reduce the cost. So this comes on both the content creation side, but also the exploitability side. So, if you have an exploitability kind of area and they're hitting your server, that's a cost for you. So we want to be able to prevent that as well. So it's a cost on a bunch of different fronts.
And it's also about getting the best bang for your buck. In my opinion, programmers should be doing the more fun, complex system kind of things, because that's kind of what I enjoy, but yes.
Yeah, so it's basically our job to empower the whole team to make the best game possible. So the first thing, and anyone who's seen me talk before will see me have talked about data-driven stuff. It is my favoritist thing on the planet. But we're specifically talking here about driving content through data and functionality. We're not specifically talking about optimizing CPU throughput, but we can, and you can kind of put those through things together and grab us afterwards and we can chat about doing those things together. But at the moment we're talking specifically about driving content and functionality with your data. So, why do we do that? So, allowing your data to drive the functionality is really important. It does a lot of different things for your game. It first gives you flexibility about and configurability. So what you're looking at here is 2 screens from Vega Conflict, a game that we worked on. Now, functionally speaking, they are different screens. They do different things in the game. But technically speaking, all the components and all the parts of them are exactly the same. That does a number of things. It means that we can use code a lot, reuse it all the time. It also reduces bugs, because if you find the bug in one place, it's in all of them, and if you fix it in one place, it's fixed in all of them. So you get much more testing on all of the various components that you're using over and over again. So it also reduces the amount of money that you need to put in your QA, because when they're testing it, they're seeing it in all these different contexts, so they actually get much more testing time on every single element. It speeds up implementation iteration times, because when you're using the same things over and over again, you can kind of tweak them and they can tweak the data and it changes it again. So, you can add a ship to it, you can add a thing, and you can actually kind of add that stuff. And adding the data, you don't need to rebuild stuff. It just adds a new element. The programmer's time is then spent setting up the framework, all those larger systems and those unique bits of functionality that are the fun bits, the interesting things.
And it's about, and part of that is driven through data binding. So you want to have your system so that you can get generic small bits of code that can bind to the actual data that is being generated and automatically update when things are happening. So if someone changes like the health, for example, and you've got a health UI, it can update automatically as an example. And you just do small bits of functionality, so like an image binder or this animation triggers based on this condition and that kind of thing. And you also, one other really big thing is to have list binders. So you may notice in like the stats panel on the side, you want to have it so that when designers add in new different types of stats, it just automatically populates and binds to the correct information.
So you don't have to manually write stats list ever again. Yay!
Yes.
Cool, oops, wrong button push. And also asset bundling. So one of the things about asset bundling is that you really would prefer to only include what you use. The number of games that I've worked on where after maybe about 6 months you have to go through an asset bundle clean because there's not really any organization and suddenly you have to remove all those asset bundles from various events. If you drive your asset bundling from your data system, you can flag things. Say, hey, this is event once only, this is event persistent. So then when the event's over, you can just pull that event once only out and that's done, it's clean. You can keep the stuff that's event persistent in the game and it stays. So things like, hey, I want a new skin for this, that comes with this event. Cool, the skin stays persistent, but all the big icons, the banners, all that sort of stuff that's the event, get that out. And so if you have it in the data set and you build your sort of asset bundles from the data that you reference, you can clean it out really quickly. I had done some projects where we kind of pivoted the game, removed the sets from the data, suddenly the game was half the size because we just removed those things from the data set and the bundle didn't pick up the stuff it didn't need to use. So it allows you to do that a lot quicker. Also allows, if you kind of do it quickly, to patch events much easier because you split up your various spins, you just send, okay, we need an event update, send only that event asset bundle. You can pull it down, the event update is fixed, much lower traffic costs, much lower data storage costs. There's a lot of things going into that. So, building for empowerment.
So it's about architecting code for non-engineering use. So what does this mean? So it's about the length of time, the length of an iteration cycle. So the gold standard is you want to have it so that if you change something, it's reflected immediately in game. This is not always possible, especially if you're doing server-driven architecture, sorry. But you want it to be as quick as possible. You don't want someone having to do a half-an-hour compile time for a small tweak. You want to be as quickly as possible. And
We want error protection. So this means that you can do things like generate a list of valid values and run that across your data set before your game goes to production. The number of times where we had, designers putting in IDs for things or whatever, and it deploys and there was a typo. Maybe the ID compare was case sensitive and they put a capital and then a lowercase, or a lowercase to a capital case. And suddenly the whole event broken, but you didn't find it until it was this sub point over here. You want to basically protect your error. You want validation go through. So you can actually either do it at change time or you can do it at a build step, add a data validator go through. Is this thing referenced? You can just do a quick check. Go, hey, it's referencing an asset that doesn't exist. Do you really want to do that? So there's things like that you can do. Or change the name of an asset. Cool, it's also referenced over here. Did you want to change that reference as well? So there's ways that you can do like that through validation.
Yeah, and you also want your data binding to be human readable. And by human readable, I mean non-programmer humans. So you want to make sure that one way of doing that is through like dot notation and stuff or something like that. So you could do ship.name, for example, and then that could find the right bit of data in your data tree. And
that doesn't necessarily mean that you can't do things on the code side to make it more efficient. So, you have on the data side, yeah, sure, free armor package 1, because that's what the designer knows exactly what it is. On the code side, you can turn that to a hashed int and then compare it that way. Like, there are ways, if you think about this ahead of time, you can optimize the code for it. So your compares are quick, you're not doing it by strings, but the data for the designer and the user is readable. So there's always ways around it. And building tools for artists and designers, this is important. It's one of those ones that kind of gets left behind, but one of the most important things about that is that you have open communication between developers and the tool users. Now, what I mean by this is, all of us as game developers are inordinately creative people. We're really good at working our way around problems, like it's what we do. And designers will inevitably go, this is not quite working, I'll just work around it. And so they'll just work around a barrier that they find, which is fine, except they don't necessarily have to. So one time I was working with a tool set and the designer like, look, it just gets a bit slow after a while, so I just close it down and open it up again and it's fine. I'm like, you can just tell me that it's slow and I can have a look at why. Turns out that the editor that we were using was caching all this data and not clearing it out because it thought maybe you might want to use it later. I'm like, no. So we had to actually force to let it go. But like, it's here, it's fixed. Now they could get through things much quicker. Work with them, I'd really like it if it could do this. Cool, let's make a templating system. Let's do whatever it is to make it quicker for them, because if you can get that iteration cycle quick, they can pump content out a lot quicker. So, system architecture. So, we're going to talk about a lot of quite complex systems and ways of doing things and all that sort of stuff. But it doesn't have to be very complex. If you're a small team and you don't necessarily have the time to invest in a lot of different stuff, you can start with the basics. So, in this, you need some sort of data, generally text-based, and we'll talk about why that is later. You'll have the behind-the-scenes part of the game, which is things like you need a way to serialize and deserialize data, and you'll need a way to load up that data and turn it into objects in the game. You then, on the play side, need some way to connect that data to elements in-game. Now, we'll talk a bit about how all that works as we kind of go along, but this is just the very bare bones. We'll talk about all the advanced stuff, but if you don't have the time, as long as you have these parts, you can do it.
And your editor could just be a notepad file.
Yes, it could just be a notepad file.
Yeah.
It could be Excel. We don't talk about Excel.
Yes.
But deserialization and serialization. This is just basically that turning it in and out of the text file. There are so many plugins and middlewares available for you for most common things. You don't have to write it. There are JSON parsers all over the place. There's XML parsers all over the place. Use something. Use the tools that are out there. There's a lot of them that are open source, a lot of them that are really good and have had a lot of testing. So you don't necessarily have to write it. You may just have to write the little wrapper between what are your data sets and what are things, but the majority of it, there are tools to allow you to do that.
And you'll be using a lot of factories. If you're not aware of the factory pattern, I'll definitely look into it because it's incredibly helpful. But you'll have factories for your data and data parsing and figuring out which class to serialize the data into. And you're also going to have potentially runtime factories where you register this type of data or it creates this instance when you're loading it up in game.
You want to make sure you use components. Now, what I mean by that are basically units of functionality that your designers can plug into whatever they want. So if they want to create a new vehicle type, they can go, hey, it's a flying vehicle or it's a whatever vehicle. It binds to these different things. It does that sort of stuff. If that's all componentized, they can mix and match them as much as they want. If they want a floating hover vehicle that does this, that, or the other, they can. So componentize your functionality as much as possible so they can mix and match all those things. And the cool thing is you can derive that through data. So they can just write the data that says, so they can, create the data that says, hi, I want a ship that does this, that, and the other, and the factories can then generate out those objects based on the data they've set. They don't even have to do any dragging and dropping in editor. They can literally do it through the data.
Oh, and no, you do binders.
Oh, I do binders. You talk about binders.
Yeah.
So binders are the way in which to sort of combine those things. Now you need to have your binders that work with your data type. So my data, this is where we have a number of points where we diverge in our approaches. I tend to encapsulate my data fairly heavily. Everything, it knows about itself and what it knows about its subparts, but it doesn't know about anything else. If to know about something else, it goes through my event system. So it's very, subscribe, unsubscribe, it's very tightly done that way. It does allow me to do some cool stuff, but it also keeps everything contained within its little bubble.
And my approach may make some people cringe, but I get the data in one big global kind of table thing. Basically, every bit of data is in one system, in one hierarchy. This allows you to have some pretty cool functionality where you can have things reference each other. And it also means it adds in extra functionality, like if you want to have your your localization system, because it's all in one system, you can just have a different root element inside there. And then if you need to change to a different language, you just swap out that thing and everything in the UI automatically rebinds because it's all bound to it.
And you do with a lot of things. You can also then go down to the root and then out, so you can refer to things without having to create a global kind of system. So there are definitely pros, but
And you could have separate instance data from type data as well. So you could have all your runtime stuff as my current health, and then it can have a redirect to its static data of this is what my max health is, and stuff like that. So it's all in one system and all easy to use that way.
But I like everything. Well, anyway.
Yeah. Different approaches.
But basically, so our approach generally is more than just an engineering thing. Yes, there's a lot of engineering parts to it, but it's built around this core belief that we are all in it together. That we're all here to serve the best interests of the game. And we're all here to support each other. We all like each other. We all think we're awesome humans. So, we're here to make each other's lives easier. Programmers, working with designers, working with artists, we're all here to help each other do the best that we can.
And one of the things that kind of started all this is early on in my career, I was one of the programmers like, oh, designers shouldn't need to edit this thing because it's very much a programmer thing. They're not going to understand it all. And then later I found out that everyone I work with is massively smart. So I accidentally exposed something and one of the really smart designers I was working with suddenly made the system do things I didn't even think were possible, which can be terrifying to begin with. But exposing everything means that expose as much as you can to them, because then they can do some crazy things with them. And then if your system isn't really supported for that, you can make it supported for that. But it gives them the flexibility to figure things out.
And also, it's about, when you do that, when you expose those values to the designers, you can then put in the protections. So you can then put in things to validate the values, to make things kind of limited. So you don't end up with crash errors and those sorts of things, but you give them the flexibility to do it. So you validate through the code, make sure you have all those correct values. Also, part of this is about having really strong architecture. Like, I can't really kind of emphasize this enough. No matter what your architecture is, it may be different for different games, but you do need a strong architecture because it will help everything come along, because you need a shared set of assumptions between all your engineers. You need to make choices that are in the best service of the team. Sometimes, it may mean maybe an extra half day for an engineer to kind of make it all flexible and make sure it has all the protections in it. But then it means that this designer can do their work in half the time. There are things like that you need to weigh and kind of, thing. So, it's about valuing all of your team members. Valuing their time, valuing who they are, and valuing their skill sets. We all are amazingly skilled humans, so let's value and support everyone.
So what does it look like in practice? So you'll have to excuse my absolutely terrible mock-up that I just kind of threw together. But this is an example for a very kind of basic version of it. So this doesn't have a server. This is just a game running on a device, so maybe on a console, or it could be on PC. So you can define all the... where am I now? You can define all your data in handwritten XML, which includes stuff like your minimum, maximum, what type of data it is, and potentially if it's localized and things like that. The game and the UI both load this same description, and they use this data to present, and the data is presented to the game in a generic format with whatever works for your engine architecture. So if you're in Lua, for example, you could just dump it all out into Lua tables or similar thing for like JavaScript. And then the editor connects to the game via a socket, and as things are edited, it's immediately reflected in game. So you can like move a slider, for example, for like speed, and you can see it speeding up and slowing down based on those changes. This works best for games without a server component, as already said. And you want to keep your data stored, so the data the designers are changing, you want to store as separate text files in different folders in the data. This helps merging later on because multiple people are going to be editing things, even if you don't think they will. And if you've ever tried to merge a spreadsheet, which I've done many times in my career, you'll understand why you want to keep it all as text. Yeah. And before I go any further, I will say try and not do any reflection at runtime because it's slow. During a load, generally okay, but if you can generate out something which will serialize it all for you without having to do reflection, that's generally more efficient.
Build time, man.
Yeah, build time, yep. And this is another alternative on how you can do it. So this is more for a case where you have a server that has multiple game clients connected, and potentially your server is in a different language. So I've used this system in the past for one which had 3 other different languages that all needed the same kind of data schema. So what you can do is you can mark up a class in your starting language, so generally the server language because it can know more information than the client can, and you can mark things as don't send this to client because the client doesn't need to know about it. And you can just mark it all up with attributes or whatever your language supports, like Scala and C# have the at tag things, which is the same, similar to sort of things. And then you can have a build step which reads all of this, and then you can generate out the classes for all the other languages. And inside the classes, you can also put in all the deserialization, and you can make it a binary formatted thing over the network, if that made sense. When you get to this point, because you've got a server connected, you don't want to reflect the variables constantly over time. Because you can imagine changing the speed value and then sending it to 1 billion connected clients. You don't want to do that, because that will probably kill the game. What you want to move to is a publishing step. So you make all your changes, and then you publish it, and then everything gets the update at that point.
Okay, so my kind of approach is fairly similar, but again, slightly different. So for me, the data schema is God. That is where everything is. Our rule book, it's a thing that basically controls all the things. And then that talks to the raw data, it talks to the game, it talks to the server. The data schema sets the rules for all of it. Now, I'll show in a minute a code-generated system that does this, and I've got a talk that talks way deep about code generation if you want to talk about that later. But you can use any sort of format for your raw data. I generally use JSON because I like it, but you can use XML or whatever. You can have data scripting, whether Python, Lua. Now, a lot of people will start to merge them. So what you'll see when you're starting to build a system like that is you'll start with something plain like JSON or XML, and then it'll start to get very scriptery. You'll start getting kind of markup scripting. That tends to get a bit messy. So you want to try and separate that. If you start getting to the point where you need that level of scripting support, separate that out. Have your data basically non-functional, but doesn't have all that functionality in it. You have your own scripting, so designers can kind of script into that. In your game layer, you have your loaders, your managers. I have what are called foundation objects, so they kind of have that deserialization calls, the things that you can kind of call into an event system. Because I make things very kind of encapsulated and they don't know about anything else, I have a really strong event system that manages anything that's bindable. In my data, in my schema, things are marked as bindable or not, or changeable or not, dynamic or not. So if the value is not dynamic, it can't send any changes to anything. So I tend to get very strict with things. And then you have any validation. So again, validation is really important. And you have your binders, your loaded assets, your custom behavior. On the server, very, very similar. And you have your loaders, your managers, your foundation objects, all that stuff things. But you also have a lot more validators. You have your transaction validators. You have validators for any competitive behavior. You have validators for any transmissions between the client and the server. You send as little data as possible. So the data system that work, because they all have that same schema, I just send an ID. A little hashed and salted thing. Now we disagree about our obfuscation, but well, that's a different thing. But we send that I send that hashed and salted ID, and the server knows what that is, and the client knows what it is. But if they fiddle with it, it just becomes a corrupted ID. It ignores it. So I try and make as little data in transit as possible. So what does that look like in actually building it? So this is a data schema. This is what I use, a code generator that I've created to basically generate all the serializers, deserializers, all the stuff that comes off it. You have my data, that's in JSON. That then, between the two, so you've got the schema there, generates out my factories. It also generates out my serializers and deserializers. So all of that stuff is generated code. I don't have to write it because it's boring. Then I have my binders. So this particular one was for a Unity tool. I have previously, now just starting to move it to a C++ tool. So I'm now writing this whole generator out to do C++, but all the schema stuff rely the same. Everything else can rely the same. It's just that generate out layout that I'm changing into C++. And then you have the tools that then connect into it. And what we can do here is we know what the things are. The data knows what things are a valid type. The data knows what things are a valid value. So when it edits the tool, they add a new ship. Cool, it just adds a new ship to the ship ID. So they can drag and drop and click. You don't have people typing things in. Just click and ding. The data knows. You have it all there. Make it easy. So, best practices.
So if you're doing a live ops game, the goal of the system is you want to make the goal of the system so that you can create an entire new entity. So if you're making like units or something, you want an entire new unit completely on the production server without a deploy. Don't actually do that on the production server. That's a terrible idea. Do it on a separate server and then copy it across. But if you make it so that you can edit an entire thing on there, it means if you need to change anything live, all of it's in the same data system, so you can just fix it where you need to. And also being able to turn off features or systems without a client deploy is massively important. So especially if you're doing like a new feature and you release it live and you've tested it all, if it starts exploding on production and you're not expecting it, you can turn it off and fix it. You want to make sure that everything has some way of being able to turn it off or disable it if needed. And you also want validation by design. So you want to make it so it is impossible for someone to enter in the wrong data where possible. And so having a small typo or a space at the end of a string, which is always a really fun one where it just fails. You want to make it so it's drop downs and things and ways that you can't enter in the wrong thing. It's still me. Is it? Oh, yes. This whole slide is me. Sorry about that. And you want the client-server integration. One thing that's really important is trust no one. You don't want the server should not trust anything the client sends, and vice versa, the client shouldn't trust anything the server sends. You should try and send the data as small as possible and send it in a binary format where possible. If you're going to move to like the data itself being serialized, you've got to remember you've got to be backwards and forwards compatible, which was a really fun challenge that I had to solve once, and I really enjoyed that. But the reason why I say that is because you may deploy a client without the server yet, so the data could be, the client could be on a further version than the server, or vice versa. You can end up in all different types. So you need to make sure you can handle everything, and everything falls back to a sane default.
Cool. Okay, so you need to make sure you have some form of ongoing performance and evaluation. This is not a one and done process. It is not something that you can just go, hey, yo, I built the whole thing, go. It would be great if you could. That would be amazing, but that's not how it works. And particularly if you start small, like with all this stuff, you want to start with this minimum viable product. You want to start with the smallest but most robust system you have, and then build as you need. Look at the needs of your team. This is about your team. So add things as needed. Don't build up everything and the bells and whistles before you actually know that you need them. But to do that, you need to have ongoing monitoring. You need to make sure that, cool, does the system work with large sets of data? So sometimes, one of the games I worked on, it started off great. The data set was fine, it was running fine. A few years later, it started to get real slow. We're trying to work out what's going on. Turned out that at some point, someone added in a ticker that was then doing some traversing between data that it shouldn't have. So we need to make sure that we monitor that. I could then refactor it, we fixed it up, it was fine. But this is the thing, you need to make sure that you keep testing it, because what you make the first time might not necessarily work for what the game becomes 5 years, 10 years time. So making sure you're having this monitoring, particularly around the size of things, can be particularly important. Because otherwise you learn valuable lessons. And valuable lessons usually involve fire. Sometimes smoke coming out of servers, sometimes out of build box. But you want to make sure that you don't have to learn those valuable lessons, that you can kind of preemptively know what's going to happen, you can start seeing the trends, and you get ahead of that before it happens. You want to keep an eye on how much traffic you were sending. So when you start off, you're sending everything really small and it's nice and neat, but over time, you start adding a bit more, and then a little bit more, and then a little bit more, and suddenly you're chogging up the networks with all the stuff that you don't need. So keep an eye on that stuff. Keep an eye on how much traffic you're sending, because maybe if you are needing to send a lot of data, you go, cool, can we batch it? Can we coordinate it in a different way? Do we need to refactor our data sets? Do we need to refactor our schemas? Because maybe we actually need to send different things. So it's really something to keep an eye on, because particularly if you're doing anything that involves sort of portable devices, you want to basically make sure you know what you're sending and how much, because that sending stuff will start chewing your battery. Same with loading and stuff. So start thinking about that early. It also means talking to your team. Are they doing the same thing over and over again when they really don't have to? So for instance, I had a designer who said, hey, cool, we're creating events, and the template's exactly the same for every single event. Cool, right-click, create event. It gives them the basic structure of the data for an event with just blank fields, and then they can fill it in. We also created one where they could say, hey, I want to create a new one of this type. So you go, create of this type, you right-click on it, and what that does is it cleans out all the stuff that we can't have duplicates of. So in our system it was unique IDs, so it would clean out all the IDs that it didn't need, but it gave them all the basic structure that was already there. I mean, the data knows it's there. It's easier to copy and paste through code than it is to copy and paste manually. You'll miss brackets and all things horribly. So let's do it through code. Let's just go grab, chuck, done. And that meant that I actually did get in trouble from the creative director because the designers were making content faster than they could design it. So I got yelled at for making it too easy. So, it's a thing. It happens sometimes. But, I think that's a good problem to have. I think the fact that our designers could create content much quicker than they could design it was actually not a bad thing. It freed up their resources to create more interesting things, to start thinking more creatively about how they could kind of make interesting things with the system. But you may still be getting the occasional why. Often happens from production or business, and they go, cool, this is a great idea, but money. Why is this important? How can we do this? So there's a number of reasons why. Spending time upfront has a whole bunch of positives. First one is actually one that we don't talk about enough, but I really want to talk about it. It helps you train your junior engineers. Now, why I say this, the number of people here, I'm sure there's many of you who've worked on really ratty code bases. And you've got a junior engineer that you're trying to change up and go, hey, never do this, except we have to do this here because of reasons. If you have a strong architecture that's got really nice clean code that you've set up for the thing, you say, hey, look, we don't actually do that here. Have a look at this example over here. It shows you how to do that thing. They can work through it. They can see it in practice. A lot of programmers, not all, but a lot of programmers work and learn best through seeing things in practice. So you can show them other examples of way things are working in a really strong architectural type. It allows your senior engineers to help and support your junior engineers, but they don't need to be dedicating all of their time to it. You can actually, help them, point them in the right direction, help the engineers learn the best way that they do through playing with the code. So it actually becomes a really good training tool. It's one of the reasons that I'm the obnoxious quality tool that I am, because I started on a really strongly typed game, and I learned from amazing engineers that then came through, so now I get very militaristic about code quality sometimes. It also speeds up feature development. So it makes it much quicker for people to build stuff because you have a strong structure. You know how things are going. So, hey, we need to build a new set of functionality for this, cool, it plugs in here, it's component-based, so we know this, we can reuse that, we can plug that in there, so it makes it a lot quicker to do. It improves stability. Because you're reusing the same code over and over again, it's getting tested, you need less QA time because they're going through those same things over and over again. You can then put in validation systems, so again, it gains more and more stability. You want a game to be stable. You don't want to be having to stay up to 3 o'clock in the morning, or, as one of my jobs, having to run 2 million save files on a server bash script because someone changed something and didn't put a kill flag on a feature. Let's just say that was not fun. That was painful. So, you can then do things like that, improve that stability. You can reuse the technology. So if you're working in an indie studio, you create a generic data set system that loads data, that does this. It doesn't care what sort of game you're making. Plug it into a different one. I've done it. I've used the same data system, so the one with the code-generated stuff in narrative games, in base builder games, in little ship fighter games, in a weird interactive narrative game with little casual clicking games. I've used it in so many different places. And it doesn't matter what type it is, because the game type doesn't care about the data. It just has data to play it. So you can reuse those core systems, and that means that they get the benefit of all the previous testing, all the previous tools that you've already created. So as a small team, that can be the make or break kind of situation. And it's quicker to pivot. So one of the titles that I was working on, we had a good, interactive narrative thing. It was like, hey, we started off with this really image-heavy kind of thing with little short kind of left-right chatty kind of situation. And like, we don't like that anymore, we want to do a completely different one. Cool. Rewrote the data, press play, rewrote a couple of binders, totally different game. All it required me was write some of the front-end binders, and then because the data system, all the saving, the loading, the serialization, none of that needed to change. It's all the same. It's the same core. The data system, the structure, the architecture doesn't care what sort of game you're using. So it was much, much quicker to pivot, which saves everyone time, because we all know never stays the same. The game never stays the same.
And it's about investing in tool development. So the more you spend on... so you can start off with a really simple tool to begin with, and then improve it over time. And you don't need to be working on a server game. You could be even a small game. Just start on small tools, and then as you're working on them, they'll get better over time and more and speed things up. And they'll speed up your future development. Speed up all feature development, no matter what type of game it is, because you can just do small tweaks and someone else can come in there and start tuning all the data and creating new things with all these systems that you're creating. And it prevents errors, because you don't want people putting it... so you want to avoid spending hours fixing something because someone did a typo somewhere and you just spent at least 4 days trying to look for it, and it was because someone put a dot in somewhere.
Or they're waiting at 3 a.m. because someone missed a backslash somewhere and we didn't have proper XML validators.
Or there's a space in the end of the string and you don't notice it in the IDE and anywhere else until you eventually find it. So you want to stop that from happening altogether.
I mean, basically, the whole reason for this, it allows your team to have sleep, have weekends, which makes for a happier, sustainable, and more productive team. Because I like sleep. I don't know about you, but I am sick to death of those 3 a.m.s and all that stuff. No, I like my sleep. My sleep is important. And I like being able to have a life. All of our developers want to have a life. We want to be able to, it makes them happier and more productive developers. So we want to be able to support them to do that. So, questions. And also, we are hiring. So if you are, a thing, come talk to us. We've got a couple of roles up there, but there's also more Keywords Australia roles out there, so we can always introduce you to our recruiter if you're not in those fields, but these are the ones that we are actively looking for right now. Yay, questions? Do you want to take the mic down or not? Nope. Yeah, take the mic down. Cool. Yes. So you've got to come close here.
How do you find applying some of these techniques to porting projects where the original game may have had a weaker architecture? Sorry.
Actually, no, that's really interesting. So one of the things that you can do is, the thing with porting is that you're often porting to very similar platforms. So you'll be porting to PlayStation, you'll be porting to Xbox, you'll be porting to Switch, you'll be porting to a bunch of different things. So you can create a layer particularly if you're doing things like a C++ engine where you have to rewrite those integrations every time. You can create a framework, a layer that kind of makes that connection. So it's a generic interface. So it is still, it's not as data-driven. Sometimes you kind of have to just live with what you've got, but you can create that idea and say, okay, we want to make our lives easier. We want to make the lives of the rest of our teams easier. So how do we do that? We work on what their problems are and try and smooth that. So if we create a generic interface that we can use between projects, sweet, it makes that bootstrapping sort of process much quicker. Yes, that means we will have to tweak. You know, there's always tweaks, there's always adjustments. Every game works differently, different hookups for things, but it does allow us to make it easier. So that's really about, because there's less design often importing, you don't necessarily have that thing, but we're still looking at how we can make the job easier for the team. And so that's about how we can create those interfaces, how we can create that flexibility to kind of support the rest of the team and make that easier. Because if we can bootstrap quicker, we can test if it's possible, we can work out where the problems are, we can kind of get that flow much quicker.
And it's also about keeping an eye on what people are doing in a repetitive way. Sorry. If someone's doing something a whole bunch of times and it's wasting a lot of time, automate it. Make it so that you don't have to do the repetitive things all the time.
Build test. I think we've got one up there and then we'll come down there. Yep.
This looks very familiar. I came up as a game modder, and as a budding designer, modding gave me the ability to try my designs in the game engine very quickly before things like Unity existed. And UDK was around, I guess, but and Unreal's awesome. But what I was saying is, like, one use case I didn't see here is, like, yes, focusing on the team, absolutely important, but have you thought about using this for, like, user-generated content or mods at all?
Definitely. I mean, more of the groups that I've worked with have not been, so it's been more proprietary, so it's kind of been conned off, but definitely. I mean, that's the whole point. You can then go, hey, this is the data set, this is the data editing tool, go, free! And then they give you the thing, they upload it to a mod server, and you can run it through a validator, check that there's nothing malicious in there, and go, cool, it matches the schema, matches the set, poop, they now have a mod that can work. So much more. I mean, I myself started modding as well in a lot of the particular RPG space. If you're ever looking at how to mod Dragon Age Origin, I may have wrote the book. So, you know, there's lots of stuff out there, but definitely. I mean, this is the thing. You can use it how your team wants to. It doesn't matter. Like, if you want to support mod and use general content, that's what it's there for. You know, you have that capacity to do that, and that's what I think is really powerful about this.
Ah, excellent. That's just really good to hear. And just some blatant self-advertising here. I work for Mod.io. We're a modding solution for game developers to use to plug in. You know, we got a Unity plugin, an Unreal plugin, and a C++ SDK if you're using a custom engine. We make modding easy. We bring modding to cross-platforms as well.
Okay, we got to answer another question. Talk to you later.
Let's talk later. But yeah,
Okay,
good
next
stuff.
one. We got a hand up here. We got to run out of time otherwise. Is there a hand up here in the... You want?
Hey, great talk, thank you. So I think a lot of teams are going to start off doing this sort of thing with just a Google Sheet, and they write an API importer for that. Obviously, that has a lot of issues like making validation hard. So for teams that are just starting out with this or aren't sure if they have the time to dedicate to building a custom solution from the first place, do you guys have any recommendations for middleware, open source libraries that can get you started on this sort of thing? Just any?
So we've done stuff in the past. We passed from a spreadsheet. So we kind of took the stuff. So the designers were editing in a spreadsheet, so like a Google Sheet or whatever. And there are a couple of plugins around to pull from Google Spreads and put it into a data set. And so I'd have a look at that. I know there's at least one for JSON, I thought, because I've done that. I've dug around that field for a while because a lot of my designers love Excel. I appreciate the fact that it's a useful tool and you don't necessarily have time to do it. You can actually also put validation in fields in Excel. So you can actually go, okay, in this field, it can only have the only valid values in this field are from this column over here. So you can actually do, if you get a little bit tricky with your XML kind of programming and validation, you can do a lot of validation at that. And so they add a ship field there, and over in that field, it adds that new to their drop down. So there is actually the capacity to do that. It requires getting a little bit familiar with some of the macro side of some of that, but it's actually not that hard. There's usually YouTube tutorials on it and that sort of stuff. So you can actually get that validation in there. So that'll help you in one thing. And then what I would do is then have an exporter. So it exports from that. It runs it into a text version. So whether it's JSON or XML, your flavor. And then you can then run it through the game. So you do have that there. And you can add the validation through macros on the actual spreadsheet itself. Any other questions? Is that okay?
I've got a bunch more if there are.
We'll go around and then we'll come back if we've got time, because we'll see. Yes, we've got a few minutes.
Great talk. I just had a question around like keeping that schema clean for designers. Like we have quite a few like one-offs, like let's say 9 out of the 10 chips all can be sold, but the first one can't because it's, you know, your basic starting chip. Do you have any ideas on like how to, or any advice on how to make it so that schema remains clean so you don't get stuck with like a large number of attributes or settings which are very confusing for people consuming the tools?
Yep, so I often have things that are in my style, because like the way I do stuff is I have some, it's like a rule set. It's a generic rule set. So then you can say it's a non-saleable rule set. And so you can then just apply, this object has a rule set. It may have no rules. It may have a 1 rule. It may have 2. And then you can go, okay, cool, well, this rule set is non-saleable. This rule set, so at least means that it's as clean as it can be, but then you can apply a generic rule to whatever. And then you have to, in my system, because the way it does, it generates out a stub, and then you have to fill in the evaluation. Because it basically, I do a lot of code generation. I like code that writes code. But basically the evaluation is then the only code that your program has to write. It goes, cool, what's this rule? This is non-sale rule. It's basically about this much code in a, you know, the partial class or in a CPP file, whichever one it works. And then you have that thing. And so you can just, the only complexity is, okay, that's this rule type. And you just go, cool, rule type, that, done. It doesn't add extra stuff, but anything can then have a rule, and so you can apply that rule to whatever you want. So maybe that you have ships that you can't be sold, or you may have decorations that can't be sold, or you may have fleets or armies or whatever that can't be sold. Cool, you can use the same thing of it. Or it may be that you have a different rule. So maybe that this one can be sold, but it comes at a reduced price or something because of these things and that the other. So there are different things that you can just apply a rule to it. So I have a generic rule system, a little mini rules engine, that basically is how I run a lot of that to keep some of that clean.
Nice. So a designer coming in would select a rule potentially if they had that requirement?
Yep.
Lovely, thank you.
So good. I think we had another one up there, and then we'll come back to you. So I'm there, at the back. Run! Sorry, backwards and forwards across the whole river, picking them farthest away. Yep.
So hypothetically, you've got a game that's been prototyping for 18 months, and they have not done any of this, and you're having some resistance from management on doing something like this. Any advice on a way in?
So I may have done bad and written it on my own time and then said, hey, magic, look what we've got here. And I don't recommend that way. It is not ideal. I think you've also...
I've also done the same thing, yes, a couple of times. Yeah.
So, you know, again, I don't necessarily recommend it, but it has at times been necessary. And I'm not recommending that. I think we should be paid for our work and all of those sorts of things. So I'm not recommending it, but I have done that in the past when I found resistance, but also being able to make the business case. So as it is a whole team effort, sometimes programmers have to learn how to talk business. So how do we make the business case for this? How do we, prove to our production team that this is actually the best way? We need to spend some time doing this. And so sometimes I call it every person in the industry has a handle, the thing that's most important to them. That's the lever that you want to pull. So find out what your production folks are really concerned about. It may be deadlines. Okay, cool. Well, if that's the most important thing, how do you guarantee that you don't make this slip the deadline? It may be that they want to, that it's a production cost. Okay, cool. So how do you make sure that this is actually not increasing the cost? So find that lever, find the most important thing to that production team, that management, whatever it is that they're most concerned about, and then work out how to apply this and make sure that it's meeting that need or not going to compromise that concern. That's how I've done it in the past. I said, hey, cool, your concern is this. This is how this will actually help with that. It actually will not make it worse. So it's learning a bit of business speak. Sometimes we have to do it to make our case for our things, but that's generally how I've gone about doing it.
Yeah, same.
Go. That's time?
That's time.
We can grab you afterwards and have a chat out the front. So yeah, anyone wants to chat afterwards or you want to kind of ask about roles, we can do that. We'll meet outside, we'll hang out outside and you can have a chat with us. Thank you.